Hello students, today we will be discussing about sampling. The objectives of this lesson are to know and define population and sample, to understand the meaning and types of probability sampling, to comprehend the meaning and types of non-probability sampling, to differentiate between probability and non-probability sampling, to describe the use of sampling, to learn how to apply sampling procedure. It is not easy to conduct research on the whole population of potential participants. On the other hand, we carry out our research on some sample from a population. We then use inferential statistics to make statements about the population based on the findings from the sample. One of the assumptions of inferential statistics is that the samples are randomly selected from the population. Sampling methods are techniques for selecting samples from a population of interest. This could either be people or organizations. By studying the sample, we may fairly generalize our results back to the population from which the sample was chosen. But before discussing about sampling methods, let us look at some of the key terms applicable in sampling. The first concept that we are going to examine today is universe or population. The group of individuals under study is known as the population or universe. In statistics, population is the aggregate of objects, animate or inanimate, under study. In sampling theory, however, the population means the larger group from which the samples are drawn. There are different types of population. The first is the finite population, which is a population consisting of finite number of objects or items. For example, students in a class. Next, you have the infinite population, which is a population having an infinite number of objects. For instance, the stars in the sky. Then there is the existent population, which is a population consisting of concrete objects such as people. And finally, there is the hypothetical population, which is the population that does not consist of concrete objects. Rather, it contains only imaginary objects. For example, the outcomes of tossing a coin infinite number of times. We now move on to understand the concept of sampling. The process of drawing elements from a population is called sampling. A finite subset of the population selected from that population with the objective of investigating its properties is called a sample. In order to select the sample, our first step is to obtain a list of the population, and this is referred to as the sampling frame. In other words, listing of the accessible population from which we will draw the sample is called the sampling frame. The number of units in the sample is called the sample size. The techniques or procedures which are used for selecting the samples are known as sampling methods. Another concept that we must be aware of is sampling error. This is the error involved in approximations about the population characteristics based on the sample that we had chosen. Any sampling scheme will have inherent and unavoidable sampling errors. Nonetheless, it is important that the researcher knows about the error in a particular sample that he or she has selected. From the graph, it is clear that as the sample size increases, the percentage of sampling error reduces. That means that as the sample grows in size, it begins to resemble the population more closely, and therefore it will be more representative of the population, and this would lead to a reduction in sampling error. The third set of concepts we are looking at is parameters and statistics. Parameter refers to the measure which is used for the population, whereas statistics refers to the measure which is used for the sample. We use inferential statistics to infer about the population based on the findings we obtained from the sample chosen. Need for sampling. The objectives of sampling are to obtain optimum results, that is, to get maximum information about the characteristics of the population without having to cover every unit of the population. And secondly, to obtain the best possible estimates about the population parameters. There are a number of factors that influence how a sample should be taken, and these include, firstly, the size of the population. Second, there is the cost involved in obtaining the elements. And third, the convenience and accessibility of the elements for the researcher. Sampling is needed when there is an infinite number of samples, and it is used because it saves time and money, it gives accuracy in measurement, it enables the researcher to estimate the sampling errors, and helps in getting information regarding some characteristics about the population. And finally, sampling helps in making correct and scientific judgment. There are mainly two approaches of selecting samples, and these are the probability and non-probability sampling techniques. Probability sampling is so named because there is the probability that any participant may be selected from a population. The sample is therefore considered representative of the population. Probability sampling has certain properties. First, the size of the population from which the sample is to be drawn must be known. Second, each element in the population must have an equal chance of being included in the sample. And third, the desired sample size must be clearly specified. Probability sampling is classified into 5 types. First is the simple random sampling. Next, you have the stratified random sampling, which is further divided into proportionate stratified random sampling and disproportionate stratified random sampling. The third technique is systematic sampling, followed by area or cluster sampling, and finally there is the multi-stage sampling. But before we look at each of these sampling techniques in detail, we must define what we mean by randomness, which underlies probability sampling. Randomness indicates that all elements in a given population have an equal and independent chance of being included in the sample. Techniques for ensuring randomness include the fishball draw method, where chits containing names of or numbers assigned to people are drawn randomly to determine who will be a part of the study. The second method for ensuring randomness is the table of random numbers, which requires assigning numbers to individuals and then randomly selecting some numbers from a table which lists out all these numbers arbitrarily. Then you have the method of computer-determined randomness, which also involves arbitrary assignment of numbers to potential participants, followed by generation of random numbers using a computer. The computer-generated numbers are finally matched with the respective individuals who will be recruited as participants. The first and a very important technique is the simple random sampling, which is a procedure where each and every individual of the population is given an equal chance of being included in the sample. The selection of one individual is in no way dependent upon the selection of another individual. Random sampling is sometimes confused with random assignments. Random assignment means that participants have been independently and randomly assigned to groups, such as in an experimental study. But in random sampling, we select some participants from a pool of individuals arbitrarily. For simple random sampling, we can either apply sampling with replacement or sampling without replacement. When an element of the population is returned to the population after being selected, it is called sampling with replacement. Alternatively, when an element of the population is not returned to the population after being selected, it is called sampling without replacement. In the case of sampling with replacement, the number of possible samples of size n would be greater than the number of possible samples of the same size from the same population in case of sampling without replacement. Imagine that a population consists of 4 persons, namely A, B, C and D. Suppose we need a sample containing 2 persons from this population through the procedure of sampling without replacement. The maximum possible samples of size 2 will be 6. How did we obtain the number 6? We have applied the formula capital N factorial divided by capital N minus small n factorial multiplied into small n factorial. Here, capital N represents the size of the population, which in our example is 4, and small n stands for the size of the sample which we need, and this in our case is 2. When we apply these numbers to the formula stated earlier, we get 4 factorial divided by 4 minus 2 factorial multiplied into 2 factorial, and this is equal to 4 into 3 into 2 into 1 divided by 2 into 1 into 2 into 1, and the answer we get is 6. This suggests that 6 combinations of 2 elements from the population of 4 members are possible for our sample, and these combinations are now listed on the screen. We can have a sample containing A and B, A and C, A and D, B and C, B and D, or C and D. We can choose from any of these 6 combinations. Conversely, if we are to apply sampling with replacement, the formula used will be capital N raised to the power of small n. Again, capital N represents the size of the population and small n stands for the size of the sample required. Since we had 4 members in our population and we wanted to draw a sample of size 2, we would do 4 square, which gives us 16 possible combinations for our sample. We could have A and A, B and A, C and A, D and A and B, B and B, C and B, D and B, A and C, B and C, C and C, D and C, A and D, B and D, C and D, or D and D as our sample. However, for the combinations AA, BB, CC and DD, we will have to reselect another element so that we have 2 different elements in the sample. This is possible because we are using the technique of sampling with replacement. The advantages of simple random sampling are that it is an easy and cost-effective technique for selecting a representative sample group. The weakness, however, is that we cannot be sure that different subgroups within the population have been included in the sample. Here, the population is divided into two or more strata which are considered to be homogeneous groups internally. Suppose we wanted to represent different religious communities, we would first divide the given population into the different religious communities existing in that population. A simple random sample for the desired number is then taken from each population stratum. Stratified random sampling is of two types, and they are proportionate stratified random sampling and disproportionate stratified random sampling. In proportionate stratified random sampling, the population is first stratified according to the known characteristics of the population, which in the example stated earlier was religious groups, and the sample is taken randomly from each stratum of the population in a similar proportion as the stratum is represented in the population. Then you have the disproportionate stratified random sampling. Here, the substrata of the drawn sample are not necessarily distributed according to their proportionate representation in the population from which they were randomly selected. Consider an example where a population of 3,000 individuals from 5 different religions reside in a particular place. Suppose that there are 1,000 Hindus, 800 Muslims, 600 Christians, 400 Sikhs and 200 Zoroastrians or Parsis. The researcher is interested to collect a sample of 300 individuals from this population. If the investigator applies the technique of proportionate stratified random sampling, then according to the proportion in the population, 100, 80, 60, 40 and 20 samples will be taken from the Hindu, Muslim, Christian, Sikh and Zoroastrian religions respectively. How did we derive these numbers? We had used the formula applicable for proportionate stratified random sampling, and this formula is given by number of people in the group divided by the total number of people in all the groups multiplied by the sample size. Now, since our population consisted of 3,000 individuals and for instance Hindus were 1,000 in that population, we needed a sample of 300. Therefore, applying these numbers to the formula, we get 1000 divided by 3000 multiplied into 300, and the answer we obtain is 100. That means that we have to select 100 Hindus from the population for our sample. Similarly, we have to select 80 Muslims, 60 Christians, 40 Sikhs and 20 Zoroastrians for our sample. Alternatively, if the experimenter is interested in disproportionate stratified random sampling, then a sample of 60 equally from each religious group will be taken to make the sample size 300. Here you will note that the groups are represented equally even though they are not of equal size in the actual population. Hence, the sample is disproportionately stratified compared with the population. By using stratified random sampling, we benefit from drawing a sample that is representative of various groups within the population. This reduces the sampling error. However, stratified random sampling is a time-consuming and difficult method. The third technique of sampling under probability sampling is termed systematic sampling, and this may be defined as drawing or selecting every kth person from a predetermined list of individuals. So what is K? It is given by the formula capital N divided by small n. Again, capital N stands for the population size, while small n represents the size of the sample required. Consider that we have 100 persons in a population and we want to select a sample of 20 from this population. Then K will be equal to 100 divided by 20, which gives us 5. So how do we go about systematic sampling? We first select any unit at random from a table which lists out the numbers. Say we selected number 4 from the table. Then we select every kth unit from this table after number 4. In this instance, we obtained K to be equal to 5, and therefore after choosing number 4, we count 5 and then get 9, and then count another 5 and get 14, and then count another 5 and get 19. So these would be the units that we would select to include in our sample. The advantage of systematic random sampling is that sampling follows a certain order which allows for quick and easy selection. However, if the list is arranged in any particular order, then this technique may be problematic. For instance, if every 5th person in our list is a class leader, then we will not obtain a sample that is truly representative of the variety of students in a classroom. The fourth technique under probability sampling is area or cluster sampling. In area sampling, generally geographical divisions of territory, community, neighborhood, cities, states and so on are made on a map, and a certain number of units from each of them are drawn at random as our sample. Let us look at some of the applications of area sampling. First, large-scale surveys of political, religious and social behavior are studied by making use of the area sampling technique. Second, where lists of specific individuals are not readily available from any database or they are inaccessible, area sampling becomes the best method of sampling. And finally, public opinion polls are easily and smoothly conducted using an area sampling plan. Sometimes cluster sampling is done in multiple stages, and this brings us to the next technique, which is called multi-stage sampling. Multi-stage sampling is applied when the area in which the study is to be carried out is huge. First, some large clusters are identified. From the identified clusters, some clusters are chosen randomly. Then, within each cluster already chosen, a number of smaller clusters are included as the sample. Cluster sampling is useful in obtaining a random sample when there is no access to a list of all members of the population. Imagine that we wanted to carry out a study on the Indian population. We would first divide the country into a number of smaller regions and then randomly select some regions. From the selected regions, we would select some households randomly. And from the selected households, we would select some individuals who would form the participants of our study. The strengths of the area and multi-stage sampling techniques include wide coverage and flexibility in selection with little expense of time and money. But sampling error could be very high in this technique. Now let's move on to non-probability sampling. A few sampling techniques are called non-probability sampling because it is not possible to specify the probability of selecting any one individual. In this technique, there is no basis for inclusion of each element of the population in the sample. This can influence the external validity because the sample may or may not be representative of the population. As the primary goal of research is to test the prediction of a theory, therefore, non-probability sampling is not usually considered a problem in hypothesis testing. The different types of non-probability sampling are quota sampling, accidental, haphazard or convenience sampling. Then you have the judgmental or purposive sampling, and finally there is the snowball or referral sampling. Let's now look at each of the non-probability sampling techniques in greater depth. First is the quota sampling. Here, the investigator identifies the different strata of the population, and from each stratum, he or she selects individuals arbitrarily until a specified number is reached. Quota sampling and proportionate stratified random sampling are very similar, with the only difference being that in quota sampling, the final selection of individuals is not random, whereas in proportionate stratified random sampling, we rely on arbitrary selection of participants. Hence, quota sampling is sometimes referred to as the poor man's proportionate stratified sample. By using quota sampling, the researcher can inexpensively ensure the representation of various groups in a population. The weakness, however, is the probability of erroneously classifying individuals to groups and consequently producing incorrect conclusions about the population and the groups. Now we look at accidental sampling. This is also known as incidental sampling. Here, the investigator selects the sample according to his or her convenience. The investigator does not care about including the people with some specific or designated trait. Rather, he or she is mainly guided by convenience and economy. Accidental sampling holds the advantage of choosing the sample conveniently and as is accessible. But this could be a biased sample leading to high sampling error. The third technique under non-probability sampling is purposive or judgmental sampling. In this, the investigator has some belief that the sample being handpicked is typical of the population or is a very good representative of the population. It is known as a judgmental sample because the investigator, on the basis of his or her impression, makes a judgment regarding the concerned cases, which are thought to be typical of the population, and therefore they are chosen to be the participants in the study. This sampling technique ensures that all individuals are relevant to the study's purpose, and their selection is done with little money and time being spent generally. But the sample is based on the researcher's subjective judgment, which could lead to a highly selective sample. The fourth technique is snowball sampling. It is an indirect form of sociometric. It is defined as having all the persons in a group or organization. First, the investigator includes a person or a group of persons who in turn identifies friends and associates until the researcher gets his or her required sample size. The merit of snowball sampling is that it is useful to study social groups and communication patterns. The weakness is that it can be a cumbersome technique when the sample size is large, such as being above 100. Moreover, it involves subjectivity in sampling and this could yield a non-representative group of participants. This lesson dealt with sampling in research. Population, also known as universe, is a group of individuals under study. In a research project, population is the aggregate of objects, animate or inanimate, under the study. A sample is a finite subset of the population, selected with the objective of investigating the properties of the population. Later, we generalize the obtained results from the sample to the population using inferential statistics. The number of units in the sample is called the sample size. Sampling is the process of selecting units, for example, individuals or organizations, from a population of interest. The approaches to sampling are mainly of two types, and they are probability and non-probability sampling. Probability sampling utilizes some form of random selection. That is, every individual in the population has an equal chance of being chosen as a participant, whereas non-probability sampling does not involve random selection. Both probability and non-probability sampling can be applied through a variety of techniques. Sampling helps to obtain optimum results and gives the best possible estimates of the population parameters. Sampling is therefore very useful as it is economical, provides accuracy, helps determine sampling errors, and allows for making scientific judgment. Sampling affects the outcomes of the study and is hence a key process in research.